I'm here again with you to create our second video about Selenium 4. Actually, I prepared the demos a week ago, but I had some sick problems. I couldn't speak, but now I'm well and we are ready to go. So let me share my screen. And in the last video, we spoke about how you can upgrade from Selenium 3 to Selenium 4. If you missed the previous video, first you can watch it. Also, don't forget to subscribe to the channel to receive notifications about many other awesome videos, and check the LambdaTest blog because there is invaluable information. In today's video, we will continue with talking about relative locators. As you know, this is something really exciting that was added to the Selenium 4 release. And what are the Selenium relative locators? In Selenium 4, the relative locators were introduced. They were previously known as friendly locators, and they can be helpful to find elements based on the relative position of other elements. For example, this email input based on the password. On the other hand, this strategy can be very sensitive to other page layouts. For example, you need to be careful when using relative locators in responsive web pages, since the layout can vary based on the viewport. And WebDriver uses the JavaScript function getBoundingClientRect to determine the size and the position of the elements on the page, and can use this information to locate neighboring components. Before, I have prepared more sophisticated examples, but let's first review the available relative locators and see them in a simple situation. And consider that we have this simple login form. And imagine that not all of the inputs can be located easily, that they don't have stable locators, right? To create relative locator, we use this class relative locator, and it provides us with this with function where we need to mention, usually by tag name, what is our searched web component. In our case, we are going to search for the email input. This is why we mentioned tag name input. And afterwards, you can use the different methods, relative locators. Basically, we'll review all of them, but you have above, below, you have side relative locators like left of, right of, near, and you can even chain all of these locators, relative locators. So using this syntax, we are saying in instructing WebDriver, we are saying, please find me the input that is just above the password, right? Because we know that in order to locate the password input, we have a stable ID. Similarly, we have the below method. If, for example, imagine that we know how to locate the email here, but we don't know how to locate the password, we can change the positions, and we can say relative locator with tag name input. But in this case, we're going to search for the password input. And we say that this input that we don't know how to locate it is just below the email that we know how to locate by ID. And as I said, we have left of and right of. This is why we can use this example for these two buttons, cancel and submit. And in this case, we say, please find me the button that is left of this submit. So we are searching for this cancel button, that it's of type button, right? It has this tag, and we say to left of this submit that can be found by byte ID submit. And vice versa, we can have right of, and if we switch the positions, right? And lastly, you can use the near relative locator. And suppose the relative positioning is not apparent or varies based on the window size. In that case, you can use the near method to identify an element that is most 50 pixels away from the provided locator. One great use for this is to work with form element that doesn't have an easily constructed locator by its associated input element. So, and lastly, you can, as I said, you can chain relative locators. So you can say with by tag name button below an email to the right of the cancel. This is totally legit to use, but be careful. It's quite easily can be become really verbose. And as we will discuss later on in this module, many often I prefer to use actually XPath instead of this long chaining relative locators. Now let's review something else. I have prepared simple web page here, as you can see on the screen, that actually have 5 input text fields. And I wanted to demonstrate that actually CSS can change the layout of the web page, right? It can, as in our case, if you observe closely, actually in the HTML, the email input is actually above the password, but through CSS, we change their positions. And if you instruct your code to type inside the next input that it's below, for example, the city input, you would expect that maybe because of in the HTML, the email input is before the password, but as I said, because we are using this special JavaScript function, it actually respects the CSS and it's going to type actually in the password. So you should be aware of this. As I said, here is the example. I'm loading this HTML file, and I'm saying relative locator by input that is just below the button, this button here. And as I said, usually this is the place for the email, but through CSS it's below. And this is why actually Selenium will type into the password input here. And now, as I said, I have prepared for you a more sophisticated example. Just to skip the hello world examples. So imagine that you have this website for searching for zip codes. I'm going to show you first how to make the scenario using XPath, and then we're going to compare it to relative locators. So now, imagine that we already opened this page here. So I'm going to copy the URL, and we want to type here a city that you're living on, and click the find zip codes. Imagine that many often if we search here, let's for now accept that we don't have an easy like an ID or something for this field here, right? Probably you can find it by name, but let's accept that for now this is something that it's changed over time. It's not stable. Usually in such cases, we in order to locate such inputs, actually we use the labels next to them, right? So if we need to work this out with XPath, we can use XPath access to find the input based on the label. And let's do that, right? So as you know, we can search and test the XPath directly in the browser. If you press Ctrl F here at the bottom of Developer Tools, you will be able to test your XPath. So first we need to locate this label here. So I can type label, and then in these square brackets, I can use the XPath method text equal, and then I can mention town/city 2 dots. And as you can see, we found this label. And afterwards, as you know, in XPath, we have this thing called XPath access to traverse the DOM on both directions. This is something that you cannot do with CSS, especially the direction up front, above. So in order to find basically the input that is just below this label, we can use the access following /sibling 2 dots input. And as you can see, we found this particular input field. And let's see, I already prepared like a skeleton of our test, right? We have a class called Relative Locators tests. Here we're using JUnit. Before all tests, we are downloading the Chrome driver. And before each test, we are starting Chrome driver. If you're not familiar how you can use Selenium together with JUnit, we have in the LambdaTest channel, I have worked on many videos regarding JUnit, so check them out. And we basically use this annotation called test to mark all of the different tests. So let's create a new test. I will delete this one for now. So I'm going to create a new test, and I'm going to void test. And here first, we're going to navigate to this URL, and we're going to find the city input using our the XPath that I showed you, and then we can type our city, for example, Sofia. Next, I will spare some code for you. Usually, when you open the Chrome, open a new session, there will be a consent screen about the cookies. This is the code just to, just to agree that we agree and find all of the cookies. And just, wrote the code for you just to work on the example faster. Now, if we want, instead of using XPath, we can try now to use the relative locators. This was the point, right? And what we can do, I'm going to name this city input 1, and let's begin to see how we can rewrite this. Well, I'm going to delete this part. Every time we need to start with a relative locator class, right? Then we need to mention with. The first part is our stable locator. In our case, we're searching for input. So here we need to mention that we're searching for input. In our case, this is the city input. And afterwards, because the label, let's review it. It's so here is our city. Usually in the HTML, the label is above the input. However, as we, if you remember the simple HTML with the 5 fields, we actually need to observe that this is actually the label is left of the city input. So don't make the mistake to mention below. We need to use left of. And here we need to mention how we are going to locate, the city. And we're going to use the rest of the stable. In this case, we're going to use the XPath label text equal to town city, which is the name of the text of the label, right? So this is how we can rewrite this using relative locators. Now, the next part of the test should be clicking on this Find Zip Codes button. If we inspect it, you will see that actually probably we can find it using this value find zip codes. However, if you work here with these tabs, you will find that there are more than one inputs having this value. And in order to make it unique, we can write an XPath that first locates this H4 with this particular title, and is just above the form that contains the input with this particular value. In order to, again, we can use XPath access. So we can mention H4 square brackets that have text equal to the title. And then here, again, we need to use following sibling because they're on the same level, right? Following sibling equals 4. And now, because the elements are inside, we need to mention input. And as you know, all of these fields here are inputs, so we need to find the one with value that contains find zip codes. Relatively long XPath, right? Equal to find here it is. Again, I know it's a bit long, however, it is what it is. So we can type this in our code, and we can click this button, right? Now, if we want to find this using relative locators, let's see how we can rework this. Well, first of all, we can, again, I'm just going to copy paste this. Again, we will use probably parts of the XPath here. We cannot skip it. But anyhow, we're going to start with relative locator with, again, we're going to search this time for inputs, and that contains this value, right? Actually, we're going to search for input that it's inside this form and has the value of find zip codes. And next, we need to mention that actually this time it is below. It is below, and now we can use the export for mentioning that it's below the H4 that contains the text find zip code state whatever. As you can see, it's a bit longer even than the version with the export. However, we can, if we name this one, we can rewrite this to make it a little bit shorter. How we can make it a little bit shorter? If we first locate the H4 like this, driver find element, we locate just the H4 through XPath, and then in this below method, instead of using the locator by XPath, we can pass the found H4. Keep in mind that this is not optimal solution, because in this case, we're going to make two calls to the driver server, right? Which usually most probably won't slow down so much your test. However, if you many often use this technique, may cause some slowness. As you know, in automated testing, we are striving to optimize everything to making our tests faster. And lastly, once we click the button, I will skip this part for you. Let's accept that we opened, for example, if we search for this, our next goal will be to click on one of these zips, and imagine that we are already on this particular page. For now, I'll just skip the rest of the code. And we want to extract some of the information here. For example, we want to get the data in a special class called zipinfo. I already created it. It contains the city, state, zip code, longitude, and latitude. And we want, based on these labels here, to extract the information. In order to store the information, instead of class, I created this record. As you know, the records are new to Java. It's basically when you use it instead of class, it will create automatically for you all of the getters, setters, to string, hash codes, and everything. And also it's immutable. It's easier for read-only data, like in our case. I wrote a code for again searching for the particular city. In this case, Sofia, or the first three letters from my name. And once we click the search, we can extract all of the links. Here I used Stream API basically to locate the table with the zip codes, and we basically extract the first 10 links from there and generates links to these special pages, and then we can for each them and save the information in a list of zip codes here. So we are going to store the information about the first 10 links, 10 zip codes displaced in this table based on our search criteria. And in order to do so, I'm going to create a private method, private string. We can call this find zip column data table. And here we're going to provide what table we're searching for. And again, here we can use XPath, and then we can rewrite this. We can rewrite this to use relative locators. The way we're going to use this, again, a little bit of more advanced Java code. We're going again to use stream. This is absolutely the same as just making a normal for each. Here I'm using stream method for each, and I'm using the lambda L means a link inside this list. First, I navigate and open this particular page. So I'm going to open this for all of the 10 links that I stored. And then we are going to call our new private method for each of the columns that we want to extract the information for the city, state, zip code, longitude, latitude, right? Let's now inspect the code and see how it looks like. So as you can see from the HTML here, it will be a little bit trickier, you know, to check the information. For all of these fields, they follow the same HTML structure. As you can see, we have two TDs here inside the table row. TD is for a column, so we have two columns. Inside the first column that it's marked as label, we have the data label, in our case, zip code, city, whatever. So based on it, we want to locate the second column. As I said, a little bit trickier. So again, Control F, and we can start our search. So we can mention that we are searching for a span that contains square brackets, text, equal, quotes, zip code. And now we selected the column, and we need, in order to use following sibling, we first need to select the parent of this span, this column. This is the parent. So we are going to use XPath access parent. And then we are going to say column. And then we're going to use a second XPath access following slash sibling dots. As I said, a little bit longer, but anyhow, we now could manage to select the column. So this is our, this is our locator, and you can use it here in these private methods. So we can say find by XPath. As you can see here, I use string format. Here you can use span, whatever. Here even we don't need this. And in the string format, instead of using the label as in the example zip code, 2 dots, basically I'm changing it to make it more generic, to pass the label here. And I'm reusing, every time I'm returning the text of the column that contains the data that we want to extract. And in this case, as I said, we're calling this method 5 times to extract the information for these 5 columns. And now, if we want to rewrite this using relative locators. We can do that. I already did this for you. We can comment the code for the expat version, and here it is, relative locator with tag name TD, because we are searching for a column, that it's right of a span with text that contains this stuff, right? And this works like a charm, not a problem. However, keep in mind, I would suggest my preference is to use expat, because you can test it in the browser. Many often, for example, it's quite easy to be confused again. For example, if you use the following stuff here, this will throw object reference exception, and you won't know what happened. You cannot test it before you run the test or debug it, right? And many often you cannot rely, because of the brackets, the dots, whatever, it's usually, it takes longer to type inside the IDE. So my preference and my suggestion is to read, that there is a really long edited out article about expat and expat access on the LambdaTest blog. So you can find this, read it, and my suggestion is, most of the time, probably for such complex scenarios, it's much better to use expat. However, if you, I don't know, maybe you find this relative locator API easier, then you're free to use it. It's there. It's good to have options, right? One last thing, as you know, in Java, we can do static imports. And basically, we can make our code a little bit shorter. So you can mention here static dot star, and we can do the same for bilocators dot star. And now we can skip all of this and make it shorter. You need to be careful using this, because if you do it, the code is much shorter. However, you cannot use the IntelliSense, right? Basically, the suggestions from IntelliJ, what are the available options for relative locator or by methods, right? But if you know all of them, maybe this syntax will be better for you. Again, this is an option to make your test shorter. I think these were most of the things that I wanted to show you about the relative locators. In our next video, we are going to talk about new next generation Selenium IDE, part of Selenium 4 release, and the new rewritten Selenium grid and all of its options about distributed testing. So stay tuned and wait for the next video. In order to get notified, don't forget to subscribe to the channel and hit the ring bell to get notified. Thank you for watching. If you have any questions, you can always reach me on LinkedIn, or you can comment below. Also, in the description below, you will find many useful links, shortcuts to the video, and of course, there is a dedicated GitHub repo where you can download the source code. You can follow the blog, and don't forget to get your free certification about Selenium and JUnit. Thank you for watching, and see you in the next video.